Hi everyone, Krishna this side and I welcome you all to this channel. So in this particular video, we will be looking into this particular problem from the lead code, largest combination with bitwise and greater than 0. So let us go through this problem statement and we'll see how we can solve this problem. So the bitwise AND is of an array. Nums is the bitwise AND of all the integers in the nums. And you guys can see here this is an array, and if we do bitwise AND, that is like if we try to do bitwise AND between these array elements, so we will get this output. Okay, so if there is only single element, definitely the AND operation gives us 7 as an output. Okay, so we have given an array positive integers candidates, so we have to compute the bitwise AND for all the possible combinations of elements in the candidates array. Okay, so we need to return the largest combination of candidates with bitwise and greater than 0. So we need to perform the bitwise and between these arrays with different combinations, and we need to get the size of the largest combinations. Okay, how many elements that we consider, and we do bitwise and between them, and we should get the bitwise and which is greater than 0. So it doesn't matter that the bitwise and should be the maximum, but the question is like when we perform the bitwise and between different combinations of this array, the output should be greater than 0. Okay, if we look into this particular example, we may see that with this particular combination 16, 17, 62, and 40, 24, when we do bitwise and between them, we are getting 16, which is greater than 0. So the size of this combination is 4, right? So that's what we need to return. So if we try different other combinations as well, even with this particular example, it is also giving AND operation. With the AND operation, the output is 8, which is greater than 0. So the maximum combination size of from this candidate array is 4, so that should be the answer. Okay, so how we can approach this particular problem, right? So if we try to do in the worst case scenario, right, if we try to take each element and try to do take the different combinations and do the bitwise and, of course we will get the size of the array, but that will go definitely in the exponential, right? So in the worst case, if we try doing different combinations from this array and try to get the answer, it will go in the exponential. So of course that is not a relevant solution, considering the length of the array is 10 to the power of 5. So of course the constraint wouldn't going to match with our solution, right? So we need to improve that one, right? So what we can do, right? So let me explain you. See, if we try to do bitwise and between 1 and 5, right? So if 1 and 5, so let me write it in binary form. So 1 looks like this and 5 looks like this, right? So if we try to do bitwise and between these, of course, and with the and operations, there should be all ones at uh, particular position, right? So at particular position, there should be all ones. Then only the and operation works. So here, if I try to do 0 and 1 between this, the and operation, it will be 0, 0 and 0. Of course, 0 and 1 and 1. So it will be 1, right? So this is what we get doing the bitwise, and the answer looks like this, and output is actually equals to 1, which is greater than 0. So what is the size we consider? So two elements, if we consider both of them, the answer is getting greater than 0. So we can see here, right? So let me take another example. I'll just take with raw elements. So again, 0, 1, 1, then 1, 0, 0. So now if we do bitwise and with let me add another element. Okay, so if we do bitwise and between all these four elements, right? So the first, second, third, and fourth, so what is the output? So here with these first three, there is one, correct? One at this particular position, but at last it is 0. So of course, if at any point if there is a 0 comes into this account, so the bitwise and will definitely gives us 0 as an output. Here also, if you look, 0 1 0 1. again, like there are multiple zeros, right? So at any point any single zero is also there, it will be zero. Again, if we look here, there is again at this particular position zero is there, so here it is zero. So there is a catch, right? So see, if we consider only this particular three elements at a point, right? So if we do not consider this one, definitely the answer is like 1, then here 0, and here 0 again. But it doesn't matter, right? So now this particular value is, of course, it is equals to 4, that is greater than 0, right? So with these three elements, the answer is getting satisfied. So what we saw here is like, if we consider the elements or the counts that for each particular digits, at each particular index of this from this elements. So here how many one are there? 1 1 0 1. So three elements, for the three elements there is three ones at zeroth index, right, from this particular element. So if we omit this particular one and only consider these three, so definitely the answer is going to be greater than 0. If you guys are getting what I'm trying to say, you will get to know the idea and you can try to solve it. So what I'm trying to say is, what we can do is basically we just try to count how many ones are there at each particular index, right? So if we able to do that, we will get to know that, okay, if here only two ones are there, so at other places, if all places there are zeros and only with these two elements, two ones are there, definitely the answer is going to be 2. So what we can do is, at each position from the array elements, we will try to count how many ones are there for that particular one, for those candidates, and the maximum ones at a particular index, if we get, that should be our answer, right? Because those many elements, we saw that they have one, and if we try to do AND operation between them, definitely answer is going to be greater than 0. So that's what we need to do from this particular example. So we'll try to count how many ones are there at each position or each index, and we will compute it with that way, right? So this will help us to do, I mean, definitely time complexity would really comes down nearly to big O of n. And if we try to consider it in another array element, so it will be n into 32 bits will be there, right, for a particular element. So those many bits, we try to check how many times one occurred at each position from this array elements, okay? And the count is what we will check, and the count is what we need to return, the maximum count, okay? So that's what we try to do here, we'll try to do here. So of course, what I'll do is I'll maintain an counts array with size of 32, okay? And we will go through the candidate array, and for each candidate array we will check uh, how many ones are there at each position, okay? And what I'll do is I'll maintain an index here, and with this index, what we will do is, for this particular counts of idx, I'll increment here itself. So before doing this, right, so what we'll do is, we need to do the left shift of this candidate, or even right shift is what we need to do. The candidate should be greater than 0, and for this particular counts of idx, okay, we will maintain candidates of candidate and 1. So what this particular statement does is, let us suppose candidate is this one, okay? And if we do AND with this particular one, the answer is 1. So what we will do is, in this particular count index, for the zeroth index, starting from the zeroth index, we will continuously keep on checking how many ones are there, okay? Now if we do this candidate and 1, the answer is 1. So the counts of index, counts of 0 at the zeroth index, how many ones are there, that is what we will able to get it from this candidate array for each elements, okay? And now definitely I need to left shift of the right shift for this candidate array. So what we can do is, sorry, let me just copy it, paste it, and we'll do right shift to this one. So what this does is, let us suppose this is what our candidate array looks like, and when we do right shift to 1, so this one will go, okay, this one will go outside, and 0 will be getting added at the end of this one. Okay, now again when we do this right shift, the we will do it, keep on doing it until the candidate goes to less than or equals to 0. Okay, so this will get omitted, then this will get omitted, and keep on 0 will get added at the left side of this particular candidate array. Once this 0 is also get omitted, the candidate is actually 0, and then we comes out of this candidate array, so that this counts of indices, how many times 1 is there, that, and in those places the 1 will get keep on incrementing in this particular counts of array. Okay, so that's why we need to do right shift of this candidate array, and yeah, that's it. Like this will do our work. We will get to know how many ones are there at particular indices from this candidate array of each element. And once we get the count, okay, we will get here the maxi, which is 0 right now, and for int I equals 0, or else let's directly get count from the counts array. Maxi equals math dot max between maxi comma count. How many ones are there? That's what we need to check. So with that, we return this maxi, and let me run it. It's pretty much straightforward. You just try to practice these bitwise operations, and most of the questions are directly falls in these categories only. But only thing is, like, we need to know how all the logical operators works, and based on that we can able to compute them. Okay, so we can solve it in other ways as well without considering this 32-bit there itself. Like, we can directly count, check what is the maximum count there itself. But yeah, that is fine. So to understand that, like, how we are writing or designing the code, I just tried maintaining this one. Okay, so with this one, time complexity is candidate array. If the length is n, so n into 32-bit is what our uh, time complexity, which is almost like constant. So n is the answer, and space is also 32, which is almost constant. Okay, so yeah, that's it from this particular question, and let me submit it as well, so that if it is working or not, we'll get to know. Okay, so that's all from this particular video. Thank you for watching this video. Bye bye.